Welcome to Quest Physics students. In this class, we are going to learn about the power of the lens. Okay, students. Often we come across with this word power of the spectacles. If someone asks you, what is your power? And one say, it has plus 1.5D. Here D means diopter. Or maybe someone tell, it has minus 0.5 diopter. Here we have to understand what is the power is. Simply, we can say power is nothing but the reciprocal of the focal length of the lens what we are wearing. Okay, students. And how we can calculate the power we have to understand. It's a very simple thing, students. Power of the lens is nothing but the degree of convergence or divergence. Is the degree of convergence or divergence of the lens. Then see, we have to understand what is this degree of convergence or divergence. And we learn that if you take a thin convex lens, okay students, and it is the optic center and it is the principal axis. Okay students, we are taking a thin convex lens. Here the rays are coming from a distant object, the incident on. After this, they get refracted and they meet at a particular point, and we call it as the focus, students. I said it is a thin, maybe it is looking very thick. Then we are increasing the thickness at the middle. Then what happens, students? Here it became much thick at the middle. Instead of meeting at this point, the rays will bend further and they forms an image here. Okay, students. See this curvature. Okay, the thickness is increased here. That means the bending capacity of the lens is increased. This bending capacity is nothing but the power of the lens, students. Bending capacity is nothing but the power of the lens, students. See, here it concentrated at a particular point. Now these rays met near to the lens. See, if you observe these rays, this one, say it is alpha. When it is thin, then see, further it has been increased to beta. That means here beta is greater than alpha. That is what we said, the degree of convergence. It is a convex lens, that's why we said it is the degree of convergence. And if you go with the concave, simply we have to call it as the degree of divergence, students. We can understand the definition clearly here, students. What I wrote here, power of the lens, I gave the definition here. The tangent of the angle by which it converges or diverges the beam of the light falling at unit distance from the optic center. And what is this? See the explanation, students. We are doing the same thing again. Here it is a biconvex lens and it is Okay, students, optic center, and here we have the principal axis. Okay, and rays are coming from a distant object here. Actually, this ray has to pass like this. It doesn't get interrupted by the lens. Then it get converged and met at a point on the principal axis. Here, this is a ray which is passing through the optic center. It doesn't get deviate, but it deviates and we call it as the principal focus. Okay, students. If it is the angle of divergence, you say it is the delta, then it's also delta. The alternate angle, students. Here, this is the focal length, students. We learn that the distance between the optic center to principal focus is focal length. And I said in definition, it converges or diverges the beam of the light. It is the beam of the light falling at unit distance from the optic center. Let's say it is the unit distance. I'm calling this unit distance as h. Okay, students. Then it is h. It is o. See, it is a. Okay, students. Here it is the delta, is the angle made by it. Here we have a triangle OFA. From triangle OFA, we are writing the tangent, student. It said that the tangent of the angle means tan delta is equal to opposite by adjacent. Opposite is what? OA by OF. Here OA is equal to H and OF is equal to F, students. In definition is said, unit distance is said. That means the H value is equal to 1. Then what we had? Tan theta or tan delta is equal to 1 by F. And this tan delta is known as the power. The power is equal to 1 by F. It is the equation for the power of the lens, students. See this? We took a triangle here and we wrote the tangent value and finally we got power is equal to 1 by F, students. Power is the reciprocal of the focal length. Power is reciprocal of focal length. Here, the unit of the power is diopter. What is the diopter? We have to understand. It is the SI unit, students. Here we took P as 1 by F. If F is measured in meter, I'm taking it as. Okay, students. Power can be written as 1 by 1 meter. That is, power can be written as meter inverse, students. Okay, students. If the power is equal to meter inverse, okay, that power is known as 1 diopter. If the power is equal to meter inverse, then the power is said to be 1 diopter. 1 diopter. 1D means what? 1 by F in meter. Okay, students.